Motion. This lesson is about Class 9 Cbse. Physics. Chapter 8 Motion. Presented by Sparkling Bookworm. Equations of motion by graphical method. When an object moves along a straight line with uniform acceleration, it is possible to relate its velocity, acceleration during motion and the distance covered by it in a certain time interval, by a set of equations known as the equations of motion. Equations of motion by graphical method. A set of 3 such equations are given below. V equals U plus at 8.5. S equals UT plus half at 2, 8.6. 2as equals V2 minus U2, 8.7. Where U is the initial velocity of the object which moves with uniform acceleration for time t, V is the final velocity, and S is the distance traveled by the object in time t. Equations of motion by graphical method. EQ 8.5 describes the velocity-time relation. EQ 8.6 represents the position-time relation. EQ 8.7, which represents the relation between the position and the velocity, can be obtained from x. 8.5 and 8.6 by eliminating t. These 3 equations can be derived by graphical method.
What do you know about velocity? Can you tell me what velocity is in terms of distance and time? Velocity is the distance covered in given amount of time. We are aware that velocity is a vector quantity and is direction aware. It's speed with direction. What about the standard unit of velocity? The standard unit for velocity is meters per second. We have also learned that change in velocity is called acceleration, and the standard unit for acceleration is meters per second squared. It is the measure of the change in velocity. So an object moving in a straight line at a constant speed has 0 acceleration. Now what we will see is the relation between all these when an object moves along a straight line with uniform acceleration. These are 3 important equations we come across in physics when we learn about motion. V is equal to U plus AT, S is equal to UT plus 1/2 AT squared, 2as is equal to V squared minus U squared. We will use U to denote initial velocity, V to denote final velocity, A for acceleration, T for time, and S for displacement or distance. Together these 3 are called equations of motion. So when we are provided with certain data and we have to find the missing information, it is very easy to calculate the answer using these 3 equations. These equations may look very daunting at first, but don't worry about it. The next few tutorials will make it very easy. We will use graphs to derive them, and that would help make it very clear and simple. What we will also see is how physics, mathematics, and geometry are linked, and the importance of being well versed in all fields. Before we start deriving these equations, you should also be familiar with the terms velocity, acceleration, and uniform motion. These form the initial part of this series of tutorials and should be referred to whenever the need arises.
Equation for velocity-time relation. Consider the velocity-time graph of an object that moves under uniform acceleration as shown in Fig. From this graph, you can see that initial velocity of the object is u, at point O, and then it increases to v, at point B, in time t. The velocity changes at a uniform rate a. Equation for velocity-time relation. The perpendicular lines BC and B are drawn from point B on the time and the velocity axes respectively, so that the initial velocity is represented by OA, the final velocity is represented by BC and the time interval t is represented by OC. BD equals BC minus CD, represents the change in velocity in time interval t. Equation for velocity-time relation. Let us draw AD parallel to OC. From the graph, we observe that BC equals BD plus DC equals BD plus OA. Substituting BC equals V and OA equals U, we get V equals BD plus U, or BD equals V minus U, 8.8. From the velocity-time graph, the acceleration of the object is given by A equals change in velocity by time taken. Equation for velocity-time relation. Substituting OC equals T, we get A equals BD by T, or BD equals at 8.9. Using X 8.8 and 8.9, we get V equals U plus at. Equation for velocity-time relation. Let us consider that the object has traveled a distance s in time t under uniform acceleration a. In Fig. The distance traveled by the object is obtained by the area enclosed within OABC under the velocity-time graph AB. Equation for velocity-time relation. Thus, the distance s traveled by the object is given by S equals area OABC, which is a trapezium, equals area of the rectangle OADC plus area of the triangle ABD. Equation for position-time relation. Equation for position-time relation. From the velocity-time graph shown in Fig. The distance s traveled by the object in time t, moving under uniform acceleration a, is given by the area enclosed within the trapezium OABC under the graph. Equation for position-time relation. Example. A train starting from rest attains a velocity of 72 km h1 in 5 minutes. Assuming that the acceleration is uniform, find I, the acceleration, and 2, the distance traveled by the train for attaining this velocity. Solution. Solution. Example. A car accelerates uniformly from 18 km h1 to 36 km h1 in 5s. Calculate I, the acceleration, and 2, the distance covered by the car in that time. Solution. Solution. Example. The brakes applied to a car produce an acceleration of 6 meters s-2 in the opposite direction to the motion. If the car takes 2s to stop after the application of brakes, calculate the distance it travels during this time. Solution. Question. A bus starting from rest moves with a uniform acceleration of 0.1 meters s-242 minutes. Find A. the speed acquired, B. the distance traveled. Uniform circular motion. When the velocity of an object changes, we say that the object is accelerating. The change in the velocity could be due to change in its magnitude or the direction of the motion or both. Uniform circular motion. The circumference of a circle of radius r is given by 2r. If the athlete takes t seconds to go once around the circular path of radius r, the speed v is given by v equals 2r by t, 8.13. When an object moves in a circular path with uniform speed, its motion is called uniform circular motion. Thank you. Please share, like and subscribe the channel.